Okay, let's try to fix up the first implementation of the stack that had some issues, and let's take this will be called stack 2, and as you can tell, this particular stack has this data that's available, that's internal, private, cannot be used by the main program, and you don't want the main program to see data, because if you allow the user to view the data or access the data, they will damage it. So it's private for sure. And pretty much the same thing is happening here as we did before. We have a default constructor with no parameters, and if that's the case, we pass it 16, and the data that we're manipulating is created in this constructor. So that's basically an integer. So let's take a look at the push. And this is really good code right here. I want you to study this code. Now, what we're going to do is do the same thing that they do in a data structure called an array list. And the JDK has this data structure called an array list. And what happens is with an array list is as you add more and more items to the data structure, it automatically grows with the number of items you put in there. That's not true with a basic array. A basic array is fixed in terms of size, and as soon as you try to add more information to that array, you get an error. So what do we got going on here? What's this? We're trying to push a number on the stack. Now we have an if statement. That's good. We didn't have an if statement in the first implementation. What we're saying here, if the top of stack is bigger than or equal to the data.length, what that basically means is, remember, top of stack can be interpreted as having the number, it can be represented as the number of items in the stack. And if the number of items in the stack is bigger than the length of the array, what have you done? What's happening? You just kept pushing and pushing and pushing until you filled up the array, and now we got the situation where you're trying to push into a full array. So what we're going to do is not output an error message, because we can fix that problem with this logic here, line 20. Let's temporarily create an array that's twice as big. This is what this is saying. Make an array that's twice as big as what you currently have now, and copy all the elements from the array you have now to my temporary location. Okay, so we've seen this before. Basically, you got to copy all the elements that are in this data array to temp. Okay, and then what we're going to do is just wipe out the old data array and assign temp to data. And now data has the array with the items copied, and it's twice as big. And now what happens in line 25, you're free to go ahead and just add that value to top of stack, and top of stack is incremented. That's beautiful code there. I want you to study that code. That's the same code that's inside the JDK array list. All right. Now with popping, we just want to make sure we can only pop a stack that has something in it. Makes sense. And we know that something's in it if top of stack is bigger than 0. Another cool way to do this, I believe, if the stack is not empty, why don't we do this? If this dot empty, okay, let's do it the cool way, and say if this data structure, if this stack is not empty, then you're free to go ahead and perform this operation. Decrement the stack and return the item that's inside the stack. If it is empty, we're going to return, we got to output something like, we can't pop an empty stack. Okay, we're going to do something like that. I probably, if we knew about throwing exceptions, when we get to that point, I would probably throw an exception instead of doing this. Because the problem with this is I'm outputting an error message, but you need to return a value, because otherwise, if you don't return a value, you're going to get a compiler error saying that there's a path that you can take that doesn't return a value. So I have to return something, so I return 0. I don't like the idea of returning anything, but so at least I I return something, but my output will have this can't pop empty stack, so I can investigate why that's happening. So we'll look at the exceptions later. So let's do a peek. A peek would look pretty much the same, only copy. Let's put this over here, copy this, paste it. If it's not an empty stack, then data of top of stack -1. Well, this doesn't change top of stack. It's just you do the calculation. Top of stack -1, grab that piece of data, return it. And in fact, you really don't need this else, because if you return, you're not going to continue on. So that's nicer code right there. If execution goes to line 31, then you have an empty stack. Likewise here. Okay. A peek is like a pop, but you don't change the top of stack. There's our empty. If it's got the empty, it looks the same. It looks the same as the first version right there. Okay, so let's see if this works. And I think I'm going to change this to stack 2. Stack 2. We'll run it, and I don't think there's going to be a problem. Let's see, it's just that the machine is slow, so that's the problem here. There it is. It looks the same. So I'm going to stop the video here. This is a quick video. And the last implementation is going to use the array list. Okay, and we'll talk. I'll espouse the virtues of array lists in the next video. Take care. Bye.